Hello students. So welcome to the JEE Advanced Pattern exercise. I've brought a questionnaire for you which includes the questions related to general organic chemistry. So you need to recall all the concepts, all the kinds of effects that we have done, the electron displacement effects, the attacking reagents, the reaction intermediates. You need to dig into the mechanism to actually get these questions right. Now let's move on to the very first question. Among the following, the least stable resonance structure. So you need to have a clarity about the resonance. So now I have got two here, A and B options, and the remaining C and D. I need to select among the following which is least stable. So that is what we need to have. Again, what I need to consider, so whenever you have such kind of questions having so many resonating structures, just try to form the resonating structures first. So what will I getting? So here, if I go by the last one, very last one. So let us just make the last one here. That means this. And a nitrogen over here. A positive. That is how we are going to make it. And now I want to convert this very structure into the C. Can I do that? Yes. I can displace these electrons, and again what I need to do? Displace these electrons again. Displace these electrons again. That is what we need to do here. So let us just have the structure. It would be like this ways. So it is, or let me just make it over here, it would be positive, negative, a double bond here shifted, nitrogen, double bond O, positive here. So I hope everybody is getting me. I have got B and C. Now if I move on to B. So this was number D. This was C. If I try to get B as my option, how can I get B as my option? So let us just first draw the B. It is something like this, and yes, that is what we need to have. Can I make it? Definitely yes. If I shift these electrons over here, and again if I shift these electrons onto here, it would have been shifted here itself. That means it is another kind of an intermediate kind of a step. That is how we getting the option number B here. Now from B, can I make it A? Let us just move on to the A. So if you correlate these two structures, I need a negative over here. Can I get a negative over here? So if you try to have these double bonds shifted, I cannot get a negative over here. That is no way that we can get these, a positive here and a negative here. That means this may not be the structure, a proper resonance structure of the compounds given. And also, what do you see over here? You see two positive charges on two consecutive carbons. This makes structure highly unstable. When two positive are coming together, this scenario is highly unstable and so much of steric repulsions will be here. That means making this very resonance structure the least stable structure. I hope everybody has got it, and the answer here is A. Now let's move on to the very next question. So what do I have in the next question? So the next question says, okay, now it is related to the hyperconjugation. What is hyperconjugation? The hyperconjugative stabilities of the tertiary butyl cation and 2-butene respectively. So they are actually asking about how the stability is going on in tertiary butyl cation and 2-butene. So that is what we need. So let us just draw. It is the tertiary butyl cation I need to form first. A positive charge, and what? It needs to be a tertiary butane. That is how what we need to have. And this is nothing but the tertiary butyl cation, and I need but2ene, that is this is the next compound that we need. And how can you draw the resonating, the hyperconjugative structures over here? So let us just see. Always the hyperconjugation is associated by sigma pi. We call it as sigma pi resonance, or also what? No bond resonance. That means here I have got an empty p orbital and the hydrogens over here. One of the sigma bonds of the hydrogens will break and the electrons will move on to this empty p orbital, and that is how the resonating structure will be. Let me just draw it. So it would be somewhat like this. It would be like this. So that is how we are getting the resonance, the hyperconjugative structure. Again and again I am telling you resonance, but it is actually hyperconjugation. Now how can I make the hyperconjugation over here? So it would be, whenever this hydrogen gets removed. So I am marking it as 2, 1 hydrogen. So now what happens? Here I have got pi electrons. So it would be a shifting somewhat like this, and these will now further move. That is how it is going to be. H positive double bond CH. This is how we are going to make it. So that is another kind of the hyperconjugative structure. So now if you see, they are asking, what they are asking, how actually this kind of a stability is happening. So they are actually considering for tertiary butyl cation the type of hyperconjugation that is happening in the orbitals as well as for the 2-butene. So if you look very carefully, in the case of tertiary butyl, what is happening? The sigma bonds are shifting onto the p orbitals. What p orbitals? The empty p orbital of the carbocation. So can you see any other option having, because sigma p filled cannot be the option, p filled again cannot be the option, sigma star cannot be the option. So for tertiary butyl cation, always there will be shifting from the sigma to the cation p empty orbital. And if you look here, sigma to pi star, how it would be? So if you see over here, these sigma bonds are shifted on to not the pi, because pi are already filled in the p orbitals. There are the p orbitals forming the pi bonds. So those are always filled here in the case of double bond. But what is not filled is pi star. Pi star is still empty. So that is what it is, sigma to pi star, because pi star orbitals are still empty. Pi are filled over here. So as per the option, we have got this very statement as also right, and this cannot be the case because pi are already filled. Again this cannot be the case, again yes, this can be the case, but here p is not filled. So I hope everybody has got the answer right. You need to analyze each and every option carefully. Now let's move on to the next question. What do we have next? Okay. The order of decreasing ease of abstraction of hydrogen atoms in the following molecule is. So here, first of all, I would like to make you see that they are asking about abstraction of hydrogen atoms. They are not saying the abstraction of proton. So how can I abstract the atom? Whenever it leaves a radical over there. So I need to abstract an H free radical, which will actually create a radical. So upon the abstraction, I need to see the stability. That is why we'll consider these 3 hydrogens and each and every case when they leave a free radical. So they are actually finding out the ease of abstraction, how easily they can be abstracted. So ease of abstraction is always correlated with the formation of free radical and its stability. So we need to check the stability of formed free radical. Stability of formed free radical. So that is what we need to check over here. So always I am saying just be very careful with the statements, especially in JEE Advanced. So these questions are really very typical. So if I try to remove this very hydrogen, I get what? I get a free radical created over here. Now is this free radical stabilized? Definitely it is stabilized by this double bond. There will be a resonance, sort of this thing. That means it is resonance stabilized. If I abstract this very hydrogen, again I get a free radical here. It is firstly the resonance stabilized first, and secondly if you see a methyl over here, this methyl will be involved in the hyperconjugation. So that will be hyperconjugations. If I abstract this free radical, what is there? There is no such resonance stabilization involved, but only what? Hyperconjugation. So that means here comes the stability. The stability will be firstly for HA, this very hydrogen, then HC, then HB. It has got stabilizations from 2 ways, hyperconjugation and resonance. So here I will be getting the stabilization from only the resonance part, and over here I will be getting stabilization from hyperconjugation, that is the least. So I hope everybody has got the answer here. It would be HA, HA, followed by HC and followed by HB. I hope everybody has got the answer here. It will be B. Now let's move on to the very next question. So what does the next question says? Most stable radical. So I need to find out the most stable radical. I have got 4 options here. Again I need to see the stabilization of the radical. This is similar to what we have done previously. So over here if you see, I have got stabilization via resonance. So that is resonance. Also what? Also hyperconjugation. And if you see over here, I have got stabilization via only the hyperconjugation. And if you see over here, I have got stabilization via resonance. So that is resonance. And here if you see, there is no such kind of not even resonance and not even hyperconjugation. So that is very, very unstable. So out of all, this is the only structure which is having 2 kinds of stabilizations. One is resonance, other is hyperconjugation. So that is our answer. I hope everybody has got the answer right. Let's move on to the next question. So what does the next question says? Okay, we have got a passage over here and it's quite a long passage. Let me just show you. So that is the passage. Let us just read it out very quickly. An organic reaction occurs through making and breaking of bonds. We all know that. So they are actually telling us about the organic reaction, how they are happening. The breaking of bonds may be occurring homolytically or may be occurring heterolytically. That is what they are saying. The neutral species, they have mentioned all the kinds of neutral species here, and the positively charged species, they are electron deficient, collectively known as electrophiles, while the neutral and the negatively charged are known as nucleophiles. An organic reaction usually involves the attack of, so they are now telling us about the attacking reagents. Radicals positively and negatively charged. What else? The substrate molecule. So they are actually attacking onto the substrate molecule. So now they are telling us about the substrate itself. It may be electrically neutral, having centers of low and high electron densities, and due to the displacement of electrons. So due to the displacement, electron displacement effects, actually these substrate are acting as prey to what? To the attacking reagents. So that means these displacements of electrons are due to inductive, electromeric, resonance, hyperconjugation effects, so and so. Whereas inductive effect, so now they are telling us about the inductive effect, they are telling us about the resonance, we all know that. They are telling us about hyperconjugation, and it involves sigma pi, we all know that. Both inductive and hyperconjugation can be used to explain the stability of carbocations, definitely yes. And for that of free radicals, they actually follow the same stability order. I hope everybody is getting it. It's a general GOC that they have explained over here. They follow the order 3 to 1. We all know that stability of the carbon ions. Now it is opposite. We all know that. Stability of the molecule can be judged on the basis of contribution of its resonance structures also. Yes. Resonance structures having the same position of nuclei, having same number of unpaired electrons. Now they are telling us about how to judge which resonance structure is more stable. Among the resonance structures, one having the greater number of covalent bonds, we have already discussed that, has less charge separations, and negative charge onto the more electronegative, positive onto the more electropositive are highly stable. So that is what this passage is saying. Take a sigh of relief. Then we are going to discuss the questions based on it. So that was the general organic chemistry that they have explained. All the kinds of effects, attacking reagents, and so and so. Now, out of the following, the one containing only the nucleophiles. So I want a group having only the nucleophiles. So what are nucleophiles? They could be neutral, they could be having negative charges upon them, but the neutral ones must be having lone pair of electrons. So if you see over here, I have got ammonia, it has got lone pairs, CN again got a negative charge, CH3OH has got lone pairs. So that is our option. Only the nucleophiles it contains. But if you see over here, let us just discuss the other three as well. Aluminium chloride having the deficiency. It's a Lewis acid, again it's a Lewis acid, but this is a nucleophile. A Lewis acid, a nucleophile having lone pairs. Here an amine having lone pairs, it's a carbene, and carbene are always electron deficient. H negative, again a nucleophile. So the correct option is always A. I hope everybody is able to sort out the type of nucleophiles and electrophiles over here. Now let's move on to the next question. What is decreasing order of stability of the ions? So here I have been given 3 cations. I need to find out the order of the stability, and that too decreasing, starting from the highest, highly stable, to the least stable. So if you see over here, cations are always stabilized by the hyperconjugation as well as plus I effect. So this has got hyperconjugation as well as the plus I effect. If you see over here, it has got what? Lone pairs, it can donate, as well as hyperconjugation, so very much stable. And if you see over here, what do you have? COCH3. That means instead of donating, it is serving as a withdrawing group. So that is a withdrawing group. So that will be the least stable structure. 3 is the least stable. I've got two options here, and which is the most stable one? The most stable one will be first one. That is this, having hyperconjugation as well as the plus I effect. I hope everybody has got the answer over here. A is the answer. Let's move on to the question number 7. Now, the most stable carbon ion among the following. So I've got A and C options here, and I've got B and D over here. So you need to find out the most stable carbon ion. So the most stable carbon ion always follow the order 1, 2 and 3. But over here if you see, I've got all the carbon ions as primary. So what would be the source for stabilization? It would be if these negative charges are very well displaced, are very well dispersed within the ring. So if there is some kind of a withdrawing group present over here, it would actually disperse the entire negative charge. So that is what we want to see. Here, do you see a dispersal? No. Over here, do you see a dispersal? I don't think so. OCH3 is not actually attracting. Now here again no such kind of a dispersal, only these electrons will be involved in the resonance, that is some kind of a dispersal. But if you see over here in the option D, it is withdrawing. It is showing minus R effect. That means it is actually taking up the electrons, that means dispersing these electrons like that. That means here it will be the most stable carbon ion. So I have got my option as D. I hope everybody has got the idea. It was very simple. You just need to have a proper knowledge of all the reagents attached. Now, I've got the match the column here. So I've got column 1 and column 2. These are the type of reactions which are actually present over here. So you need to match it. So let us just start from the very bottom. I've got cis-2-butene converted into trans. Cis is getting converted into trans. That means one isomer is getting converted into the another. I've got my answer as E is correlating with the Q. Now if I look over here, these two compounds are there, and in the next reaction what do you see in the products? You see that two compounds are actually getting attached together, that means getting condensed. So what type of reaction is that? Condensation reaction. Now coming on to this very reaction, here Y has replaced the position of X, that means substituted the place. Again I've got my answer, substitution reaction. Over here if you see, OH is the nucleophile, it is attacking over here, and from this chloroform molecule, H and one Cl got removed and we get a carbene over here. That means the two things have been eliminated and we get the answer here as elimination reaction. What I am left with is the rearrangement reaction. That is nothing but this. If you see over here, this is a kind of a rearrangement of the atoms over here in order to form urea. So I've got my rearrangement reaction as well. So A corresponds to R, B corresponds to S, C corresponds to T, D corresponds to P, and E corresponds to T. Sorry, E corresponds to P. E, okay, it is Q. So that means we have got the set of answers over here, and let me just match it. So if I match it, I get, okay, A corresponding to R, that means C as the option, correct? So I hope everybody has got the answer here. Let's move on to the very next question. The second last question of this questionnaire. I hope everybody is getting clear with the questions here. So it's the integer type question now. We all know we need to answer into integer forms. The total number of contributing structures showing hyperconjugation. Again, you need to find out the hyperconjugative structures. The number of alpha hydrogens will give hyperconjugative structures. So you just need to count the number of alpha hydrogens present over here. It's 2. This is the carbocation here. Corresponding alpha hydrogen is this. Corresponding alpha hydrogen is this, as well as this. 1 hydrogen over here, 3 here, and 2 here, in a total of 6. Hyperconjugative structures is the answer. Answer is 6. So that was too simple. Now let's move on to the next. So the next question says, it's an assertion reason type. So again, what all options you need to mark here, let us just discuss. I have got 2 statements in assertion reason. One statement is true, second statement is true, 2 is the correct explanation of 1. One statement is true, 2 is true, 2 is not the correct explanation. Statement 1 is true, statement 2 is false, statement 1 is false, statement 2 is true. So I need these type of options for a correct answer. So let us just analyze statement 1 and 2. Now, statement 1 says free radicals are always planar. Is it? Free radical is actually having such kind of a structure. These are the 3 hydrogens. I am drawing it for the methyl free radical. Here it is the free radical, and this is contained within this empty p orbital. This is having a trigonal planar structure. And hybridization sp2, definitely yes. But sometimes what happens is, in order to arrange this free radical, let me just draw this free radical over here. So in order to arrange this one single odd electron, this molecule sometimes attains pyramidal shape as well, just like in the case of carbon ions. And that is how the pyramidal shape is attained. So this is nothing but a pyramidal shape corresponding to sp3 hybridization as well. So that is what the theory for free radicals says. Now let us just analyze the statement number 1. Free radicals are always planar, is it? No. This statement is incorrect. They can achieve sp2 as well as sp3 hybridization. This statement is correct, but statement 1 is false. So only one option we are left with is statement 1 is false, statement 2 is true. So that is what it is. We need to mark out D as our option. So that is all in the case of the general organic chemistry JEE advanced pattern. I hope everybody is clear with the questions, everybody has followed up. If not, just try to go through it once again, and then you will have a good practice of it. So I'll be back with another chapter in the next session. You just need to revise and practice what all we have done so far. Why? Because this very particular chapter is very, very important. It holds a lot of weightage. So till then, have a good day.